Hi, welcome to another video series on complex numbers. I am Hari Prasad from IAM, Institute of Academic Mathematics. In today's video, we are going to look into the three questions. What is I in complex numbers? Where can we use complex numbers in real life? And the third question is like, what are the powers of the imaginary unit I? What is I? I is an imaginary number. Imaginary numbers in complex numbers are represented by I. Where do we use complex numbers in real life? Engineers, doctors, scientists, vehicle designers, and others who use electromagnetic signals use complex numbers for strong signals to reach the destination. It is used in signal processing, control theory, electromagnetism, fluid dynamics, quantum mechanics, cartography, vibration analysis, and so on. Now let us look into the powers of the imaginary unit I. Let us start with I power 0. I to the power 0 is nothing but 1. I to the power 1 is nothing but I. Anything to the power 1 is the same number. For example, if you have a pen to the power 1, it is a pen. If it is 10 to the power 1, it is 10. If it is 100 to the power 1, it is 100. So anything to the power 1 is equal to the same number in mathematics. Now moving on, let us look into I square, that is I to the power 2, which is nothing but minus 1. These are the three rules that you have to remember in complex numbers for calculating the imaginary unit. Okay. Now let us work out the values of I power 4. So I to the power 4 is equal to, how can I write it? I can write it as I square into I square. So what is I square? We already know the value of I square, which is nothing but minus 1 times minus 1. What is minus 1 into minus 1? It is a plus 1. So I power 4 is nothing but 1. So with these three values, with these three rules or values that we have to the powers of imaginary unit I, we can compute any number of powers of the unit I. Okay. So now let us take another example of I to the power minus 3. Okay. How can I write I to the power minus 3? I can write it like 1 by I power 3. So I don't know the value of I power 3. Do I? I don't know. I know the value of I power 1, I power 2. How can I do it? Okay. So I'm going to times it by I power into I into I. So I power 1 into I power. So I'm multiplying the numerator and the denominator by the same value so that the end result is not changed. I'm repeating once again. I'm multiplying the numerator and the denominator by I so that the value doesn't change. So what is the end result? It is going to be I divided by I power 4. What is the value of I? I power 1 is I. This is the one. So do we know the value of I power 4? Yes, we know. It is 1. If we do not know the value of I power 4 instantly, we can do the same method that we did, I square times I square minus 1 into minus 1, it is plus 1, and you know that it is 1. So it is 1. So what is I power minus 3 is equal to I. So given any circumstances, you can compute the value of the imaginary unit by yourself. Now let us work out another complex examples, okay, to get more confidence on the imaginary power units. Okay, so let us start with I to the power minus 1928 plus I to the power 2018. Okay, so how we can write this? So 1 divided by, so this one I'm going to write it as I to the power minus 1928. Okay, it's a big number. 1928 plus I to the power 2018. Okay, now we already know I to the power of 4 is equal to 1. So that's the simplest way to calculate things. Okay, so now I'm using this as a rough column. So always have your rough column separate. Okay, and draw it as a rough column. So I'm going to divide 1928 by 4. Why am I doing this? If I do it like that, the benefit is like I can capture the numerator and the denominator whichever is divisible by 4, and I can equate to the power of I as 1, and the remaining I can equate to the I square or I power 2 and or I power 1, the remainder, and I can calculate the imaginary power. Okay, so I'm going to cancel it by 4, or let us cancel it by 2 for simpler things. Okay, so I'm going to cancel both by 2. So if I cancel it by 2, it's going to be 2 here, and if I cancel it here, it is going to be 9 times, and I'm going to carry forward 1. It is going to be 6 times, it's going to be 4. Now once again I'm going to cancel it by 2. Okay, so it is going to be 4 8 2 is going to be 482. So that means like this number 1928, we took 1928, right? It is completely divisible by 4. So is divisible. Okay, so what does that prove? So we can write it like I power 4 of so and so. So I'm going to write it like, the moment I find that it is divisible by 4, I'm going to write it as 1. Okay, anything to the power 4. So for example, I'll give you a small example, I to the power 8. Okay, so what is I to the power 8? I'm going to take this 8, okay, and divide it by 4. 8 divided by 4, what you get? You get 2, right? So 8 is divisible by, likewise 8 is divisible by 4 is divisible. I'm going to write, I'm trying to give you a simple example, and once again relating it to a bigger number. Okay, I'm taking a simple number to prove the logic, and then I'm going to map it to a larger number so that we can all understand. Okay, so I power 8, so it is 2, so I can write it like 1. So sir, how can you write it as I power 8 is equal to 1? That's my logic. Okay, I will prove that now. So I power 8 is equal to I power 4 times I power 4. You already know I power 4. I power 4, we already know it here. Okay, it is nothing but 1 times 1. 1 multiplied by 1. So it is 1. So I power 8 is equal to 1. Okay, so that's what we have proved it here. When we are able to divide any number by 4, and if it is divisible, then we can simply write it as 1. That's another rule. Okay, if you are able to divide, I'm repeating the rule. If you are able to divide any power by 4, and if it is divisible completely without any remainder, then we can write it as 1. Okay, now let us take another one. Okay, so I'm going to have another rough column here. Okay, this is also another rough column. Okay, so we need to find I to the power 2018. Okay, now once again, what is the rule? We have to divide 2018 by 4, divided by 4. This time I'm going to divide it directly. Okay, so what is 25, then 0, then what it is 4 times, I got a remainder of 2. Okay, so then what I have to do with this 2? Okay, so now you got 2018, right? I can write 2018 as 2016 plus 2. Okay, So this 2016, I got the remainder, right? See, I'm computing with the remainder. Okay, I got the remainder as 2. So if I'm subtracting 2018 with the 2, I'm getting 2016. So 2016 plus 2 is equal to 2018. This number, I'm sure, like, it is divisible by 4. Okay, if you want, we can do it and see. So 2016 divided by 4. So it is 5 times 0, 4. It is completely divisible. Okay, so the next thing is like, what I have to do, what can I do with this 2? Okay, we'll do go step by step. So we can say like I to the power 2016, sorry, 16 times I to the power 2. Okay, so I'm going to write 1 by 1 as 1, and anything which is divisible by 4, we are already writing it as 1 times I square. What is the value of I square? We already have done it. I square is nothing but, what is the rule? It is minus 1. So 1, using Bodmer's rule, we have to first do the multiplication. It is going to be minus 1. Okay, which is equal to 1 minus 1, which is nothing but 0. So I to the power minus 1928 plus I to the power 2018 is nothing but 0. Now let us work out another complex example. Summation of I to the power n, where n is equal to 1 to 102. So you might get some questions in your board examinations like this. So how to work this out? Okay, so what does this basically mean? This means like I plus I square plus I power 3 plus I power 4 plus I power 5 up to tick 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 up to 1 I power 100, I power 101, I power 102. This is what is the meaning of it. Okay, so how can I combine it and write this? Okay, so I'm going to write this, I'm going to consider this as a rough column anyways. I'll write it as rough for our reference. I'm going to write it like here. Okay, I plus I square plus I power 3 plus I power 4 plus I power 5 plus I power 6 plus I power 7 plus I power 8 plus dot 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 plus I power 97, I power 98, I power 99, I power 100 plus I power 101 plus I power 102. Okay, so now what all values to the powers we already know? We already know I to the power 1, I to the power 2, I to the power 3 and I to the power 4. Can we write it down so that it makes our life easier? What is I power 1? Anything to the power 1 is the same number. I to the power 1 is I. If you have 2 to the power 1, it is 2. If you have 10 to the power 1, it is 10. Okay, so always remember this rule in mathematics. What is I square? I square is nothing but minus 1. What is nothing but I to the power 3? I to the power 3 is I. What is I to the power 4? Is nothing but 1. So we are going to solve the whole sum by remembering these rules. Okay, these rules are formulas, you can call it as. Okay, these rules are formulas. I'm going to repeat it for you. It is I power 1 is I square is nothing but minus 1, I power 3 is minus I power 4 is 1. Okay, so now we have got all the values. Okay, so I'm going to split the values by 4. Okay, so we already have done one example. Anything divisible by 4, I can write it as, for example, I power 5. Okay, let us take this example. What is the remainder in this? if you divide by 4, 5 by 4 is equal to 1, and what is the remainder? Remainder is equal to 1. Okay, so I can write it as I power 4 into I power 1. So what is I power 4? I power 4 we already know. I 1, sorry, I power 4 is nothing but 1, and we have I times I, which is nothing but I. So I power 5 we got it as I. Okay, likewise we'll get I square, I cube, and I to the power 4. Okay, so I'm going to write it like this: I plus I square plus I power 3 plus I power 4. Okay, I'm going to put it in a bracket. I'll tell you the reason for that, okay, in a minute. So next I'm going to combine these four values. I'm going to write it like I, which we got it here. Okay, extend the rough column, plus I square plus I power 3 plus I power 4. Okay, dot 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 dot, and likewise here as well we can write it like that. 96 will be divisible by 4, so we have the remainder 1. Okay, so I'm going to write it like I power 1, I power 2, I power 3, I power 4, plus what I have to do with the remaining two numbers. I'll write it like that. Okay, what is, if can we divide 101 by 4? Yeah, we can divide 100, and we have got a remainder as 1, right? So we would write like I power 1 plus I power 2, right? So now we will write the values here. What is I power to the power 1 is I. Okay, I square we know it is minus 1. Then we know I power 3. I power 3 is minus I. What is I power 4? We know it is 1. Okay, likewise we can repeat the same because all the values are same, right? So it is going to be I'm going to quickly write it for you: minus 1 plus of minus I, and what is I power 4 is nothing but 1. So dot 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 dot. So we have written this and we have written this. Okay, now we have to write this and this. Okay, so I'm going to go to the next line and continue it. So what is I power 1? I power 1 is nothing but 1. What is I square? I square is nothing but minus 1, this one, plus I power minus 3. What is I power minus 3? Is nothing but minus I plus I power 4. We already have memorized this now. I power 4 is nothing but 1, plus we have to write the remaining. I power 1 is nothing but I plus what is I power 2 is nothing but minus 1. So if you see in here, this and this we can cancel this and this we can cancel this. Okay, in order to understand more about the cancellations, you can look into other videos in our channel and understand how to cancel numbers and divide and all those transactions. Okay, how to work out. These are all basic algebra. At this level, in this video we are not covering how we are cancelling in this. Okay, so you can refer to the other video tutorials. The result of this cancellation is going to be 0. So any brackets whatever we are going to get is going to be 0, 0 and 0 here as well. So this I can once again divide it by this, cancel it, and this one, I'm sorry for telling it as a division, it's cancellation. Okay, or 1 minus 1 is equal to 0, I minus I is equal to 0. Okay, and this one, sorry, this is I minus I, we are cancelling it, and 1 minus 1 to the 1. we are making it as 0. So it is going to be 0 plus 0 plus dot 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 plus 0 plus I. I'm going to write it as minus 1. So what is the end result? It is going to be I minus 1. So we'll write the question here. Summation of I to the power n, where n is equal to 1 to 102 is equal to I minus 1. This is your answer. Thank you for watching this video on complex numbers and to the powers of imaginary unit. If you have any questions, please feel free to add it to the comment section. I'll try to answer them as soon as possible. Thank you.